Okay, good day, ladies and gentlemen. Welcome to lecture 2. Okay, so in the last class, we discussed mean, median, and mode of ungrouped data. So today we will be talking about mean, median, and mode of grouped data. So you've got to follow this course well. It's actually explanatory, but let me still take my time to explain it. So lecture 2 is grouped data calculation, and we'll be looking at mean, median, and mode. Actually, mean of grouped data is not difficult at all using the same or a similar method, and more so the median. We have various median trying to calculate location, and I will still give another course. I'll still give another course explaining measure of dispersion, measure of location, like clarifying that aspect, as some of you have questions with respect to that. All right, so I would start straightly with mean. So take a look at the lecture here. Mean. So an example is here. The following tables give the frequency distribution of the number of orders received each day during the past 50 days at office of a meal order company. Calculate the mean. All right, so you have the number of order and then you have the frequency. This is in form of interval. 10 to 12, 13 to 15, 16 to 18, 19 to 21, right? Now, for us to get the x, mean actually has a summation fx over summation f. Now, we need to get our x here. So how do we get the value of x? We add these two values together, then divide it by 2 to find the average. The same thing for the next one. The same thing for the next, and till you. So when you add 10 plus 12, it's going to give you 22. Divide it by 2, you have 11. Add 13 plus 15, divide it by 2, you have 14. Add 16 plus 18, divide by 2, you have 17, and on and on. That gives you your x. Now, for you to get the next table, you have to create this next table fx. That's the multiplication of this times this gives you fx. So you have 4 times 11, that's 44. You have 12 times 14, that's 168. 20 times 17, that's 340. And then finally 14 times 28, that's 280. Alright, so the whole values here, everything you have here, sorry for my wrong drawing. So everything you have from this place to the end, all you just need to do is sum them up. That gives you your fx. Now, the frequency, it is actually summation fx over summation f, right? And your summation of f is this n that you have there, and the n is 50. So here explains by x. By x is the same as the mean, and that's summation fx, which is 832, divided by summation f, which is n, and that's 15. That gives you the mean. That's how we get the mean. Now I'm moving to the next class, median and interquartile range. So I spoke earlier that median, you can have the first quartile, the second quartile is actually the median, then the third quartile, obviously no fourth quartile. Okay, now we look at the next one, which is the median. Now you have to understand this. Here is the formula for finding median. Median is, you have Lm plus n over 2 minus f all over fm, f subscript m actually, then times this I here. Some of your master's book, especially new general master's book, would represent this I as C. So median, the formula for median is L subscript m, and this is the formula for median. All right. Now, this L subscript m, the the meaning are actually given here. You have LM is the lower boundary of the median class. Sorry, let me just explain the meaning. Then FM is frequency of the median class. F subscript M is the frequency of that median class. Then F is cumulative frequency before the median class. Then N is the frequency. Then that I is the class width. Now, how do we get the cumulative frequency? We're going to see that. Then, and we've been saying median class. Well, where is the median class? The median class, we need to find the median first before we now proceed. Okay, so don't worry, you understand. Look at this example to explain this. So based on the group data below, find the median. Now, look at it. First step is to construct the cumulative frequency. You know, I've been able to get a material that will help you understand this to the highest, to the deepest part. Now, so first step is to construct the cumulative frequency. So what we do is we write the first value, then the next one that we are going to get here will be added to 14. That is 8 plus 14 will give us 22. This 22 plus 12 will give us 34. 34 plus 9 will give us 43. 43 plus 7 will give us 50. That's it. We've been able to write out the cumulative frequency. Now, we need to get the next values. Look at F. It said F, we need to first find the class median or the median class. And that's this formula. N divided by 2. That's 50 divided by 2 gives you 25. You know that the median class is at 25. So what you need to do is, where can we find 25? We'll come to the cumulative frequency. Here is 22. We cannot find 25 in 8. We check 22. We cannot find 25 there. We can only find 25 in 34, right? So this is where our median class is, or class median as it is written here. Now we then start. F is cumulative frequency. This F here is cumulative frequency before the median class. And we know that our median class is at 34. So the cumulative frequency before it is 22. That's why we have 22 here. FM is frequency of the median class. This is the median class here. Is at this part. Right? Now the frequency is 12. L is the lower class boundary. Now in this material, I didn't show you where you can construct the class boundary. So class boundary is reducing and increasing on the other side up to 10.5. The other side will be, when you reduce 11 by 0.5, that will be 10.5 to 20.5. This 21 will be 20.5 to 30.5, like that. Now, the lower class boundary. So here is from 20. Let me draw it so you can see. Right, so you can see 20.5 to 30.5. And we already know that the median is around here, right? So the lower class boundary, this is lower class boundary, upper class boundary. That is 20.5 is lower class boundary, 30.5 is upper class boundary. Now, the lower class boundary of the median class is this LM, and that's 20.5. Then the class width, that's 30.5 minus 20.5. Not 10 minus 1, no, not 20 minus 11, no. Is the width, it's called class width of the class boundary. That's the ones you reduce 0.5 to 10.5, then 10.5 to 20.5, 20.5 to 30. The width there is 10. That is 30.5 minus 20.5. That gives you 10. Then all you need to do from here is start inserting the values. You already know that the lower class, the boundary of the median class is 20.5. Then plus into bracket n over 2 is 25 minus frequency of the cumulative frequency before the median class, that's 22, you put it, then over frequency of the median class is 12 times 10, which is the width. Now here is lower class boundary of the median class. That's a mistake there. It's not supposed to be 21.5, it's supposed to be 20.5. So pardon me of that. I'm so sorry. Alright, so putting the values there, you have 24. Okay. We've been able to answer the question. Quartiles. Now if you look at this particular quartile, it's still the same thing though. All you just need to do is to find quartile 1, it to be n over 4, sorry. Quartile 2 is median, that's why we're saying n over 2. Quartile 3 is 3n over 4. You would wonder why this one n over 2 is because here is n over 4, next one is 2n over 4, and 2n over 4 is n over 2. That's why the median, we're always using n over 2 to get the position of the median class. Now, we want to find quartile 1. We need to get the position of quartile 1. So we say n over 4. So we need to do n over 4 first. Once we get n over 4 is 50 divided by 4. That should be around 12.5. So you go back to your table and locate where 12.5 is. 12.5 is around here. Then you now start, okay, lower class boundary of quartile 1 is 10.5. Then frequency before quartile 1 is, sorry, cumulative frequency before quartile 1 is 8. Because we already know that quartile 1 is around here. Then frequency of quartile 1 is 14. Then the class width is 10. We insert the values there. It will give us our answer. Look at it. You see that? Lower class boundary of quartile 1 is 10.5. As I said earlier, then 12.5 minus 8 all over frequency of quartile 1 is 14. Do you understand my point? Is quite easy. The same thing you do for quartile 3 or third quartile. Third quartile would be 3n over 4. This place will not just be n over 4. It will be 3n over 4. You get? Then the same approach. Locate your third quartile, that's Q3. By that approach, you get it. Then we are good to go. Let me just explain this. Okay, so 3n over 4 is 37.5. Look for where 37.5 is. Where is 37.5? This is 34. We are using the cumulative frequency to judge you. We cannot find 37 here. We cannot find 37 here. We cannot find 37 here. We can only find it here. So this is where it is. This region. So what is the lower class boundary of quartile 3? That's 30.5. What is cumulative frequency before the median class? 34. Frequency of frequency of quartile 3 is 9. Then class width is I. Now, so when you insert those values, you look at it, you have this. Now, interquartile range is Q3 minus Q1. So interquartile range is Q3 minus Q1 over 2. You've gotten your Q3, you've gotten your Q1. Put in the values, divide by 2, you get your semi-interquartile range. This is very simple. Now, I'll go to mode of group data. Mode of group data is not difficult at all. It's not difficult. All right. The mode. Okay, so you have the formula for mode. Lower class boundary of the modal class. Okay, so you have LMO plus this value. Now, I want to look at what each represents. Look at it. This delta 1 is the difference between the frequency of the modal class and the frequency after the modal class. Don't worry, you understand. This one is the difference between the frequency of the modal class and the frequency before the modal class. You get it? Very simple. Then Lm is the lower class boundary of the modal class. Then I is the width. So let's go. Let's calculate it. Let's use the same example. Now this one, they say calculate the mode. So what we need to do is very simple. Just get the lower class boundary. First, we already know that mode is the highest occurring value, right? So what is the mode from this frequency? We don't have anything to do with cumulative frequency in the aspect of mode. The mode here is, this is where the mode is, right? This is where the mode is. Now, the lower class boundary of the modal class is 10.5. Now I told you, I said the way we write that interval is 0.5 to 10.5. We reduce one side, we increase the other side. 10.5 to 20.5. 20.5 to 30.5 and on and on. Okay, now we already know the lower class boundary of the modal class. The modal class is 14. So what is the lower class boundary? We reduce this one, that's 10.5. And then this change in one means the frequency before, the differences between the frequency before and on that modal class. The modal class is 14 minus the frequency before it, that's 6. And the other one is the frequency minus the frequency after it, and that's 2. So your mode becomes 10.5, which plus 10.5 plus in bracket 6 over 6 plus 2 in bracket 10, which is the width, is equals to 17.5. Once you sum this up, you get the value for your mode. Alright, so I'm going to be teaching this in the next class, teaching variance and standard deviation and all how we can get all this. Alright, so just pay attention to the next class and then we'll be good. Alright guys, so thank you so much for listening.